Next, we're going to look at factoring when the coefficient in front of x squared is not 1, like the examples on this page. So notice the number in front of x squared is not a 1. Not a 1. And also, these aren't all divisible by 2, so I can't factor out a GCF on any of them. So what do? So let's review for a minute. I've got two binomials, and we're going to multiply them together. So 2x minus 3 and 3x plus 4. So 2x times 3x is 6x squared. 2x times 4 is 8x. Negative 3 times 3x is negative 9x. And then this is a negative 12. So I really want to look closely at these two middle terms, because those are the ones that are going to add together. They're my like terms. So in my final, I'm going to have 6x squared, and the middle term is negative 1x. I'll write that 1, and then minus 12's at the end. Now previously, these two added to be the middle term, and that's fine, they do. They add to be that middle term, negative 1x, which is the middle term. But they're not multiplying together to be the last one. 8 times negative 9 does not give me a negative 12. What do these multiply to be? Well, what's 8 times negative 9? That's negative 72x squared. There's a neat thing that happens here. What do I get if I multiply the other diagonal? So in other words, the first times the last. Well, if I multiply 6x squared times negative 12, I get negative 72x squared. That's the same thing that negative 9 and 8 multiply to be. They multiply to be a negative 72 too. So I like reversing the process on the multiplication box when I have a coefficient in front of my x squared. So we're going to draw the box, and we're going to talk about how we're going to reverse the process. Well, I know from this last example that the first term always ends up being here. That's my first. And the last term goes here. But those two middle terms, I can't tell what they originally were. All I can see is what the end result once we combined like terms. So there's a couple of things I know about the missing terms. The missing terms add to be 7x. They add to be the middle term. Now, just knowing two numbers add to be 7 doesn't help me much. I need to know what they multiply to be also. So to figure out what they multiply to be, I'm going to take 2x squared times the 6. So some people like to do it up here. 2x times 6, so that's 12x squared. So I know these two missing terms are going to multiply. Well, really, we're thinking about these coefficients because I know that both of them had an x. That's a given. They multiply to be a 12 and add to be a positive 7. So remember what we did yesterday. If they add to be a positive, they're both going to be positive. So 1 times 12, 2 times 6, 3 times 4. Oh, there they are. So I can put them in any order I want. I'm going to put the 3x there and the 4x here. Now I've got to figure out those outside edges of the box. What goes here? Well, let's look back at this one. 2x went into both of these. It distributed into both of these terms. 2x times 3x is this. 2x times 4 is this. 3x is the greatest common factor for these two. So let's start with the first row. What's the greatest common factor? What would have been distributed to get both of these? Well, the only thing they have in common is an x. Now it's like a little puzzle. X times what is 2x squared? Well, that has to be a 2 and another x. X times what is 3x? Well, that'd have to be a positive 3. Now let's do the bottom row. What do these two have in common? What's their greatest common factor? Well, both of them have a positive 2. Now let's double check. X times 2x, x times 3, 2 times 2x, 2 times 3. So my factors are x plus 2 and 2x plus 3. Let's try the next example. First term, last term. The two missing terms are going to add to be 8x, and they're going to multiply to be the first and the last together. First and the last together. First and the last together. So that's negative 33x squared. Ooh. Negative 33. So that means one's positive, one's negative. Let's think about some things that multiply to be negative 33. Negative 1 and 33. That's not going to give me 8. Negative 33 and 1. Nope. How about negative 3 and 11? Negative 11 and 3. Which one of those options gives me 8? Yep. So this is a negative 3x and a positive 11x. Oh, that made it easy. What do 3x squared and negative 3x have in common? Gosh, that's easy. They have a 3 and an x. So 3x, I like to just start with that first row. 3x times what is 3x squared? Well, that has to be an x. 3x times what is negative 3x? That has to be a negative 1. What do I need out here to make the puzzle work? What do they have in common? Well, they have an 11 in common. 11 times x is 11x. 11 times negative 1 is negative 11. 2x squared plus 5x minus 18. (2x squared and negative 18). Those always go in. I don't have to do any figuring to figure those out. But the missing terms are going to add to be 5x, and they're going to multiply to be negative 36x squared. We're really looking at the coefficients here. Add to be 5 and multiply to be negative 36. So multiplies to be negative 36. That could be a negative 1 and a 36, a negative 36 and a 1, a negative 2 and an 18, negative 18 and 2, negative 3 and 12, negative 12 and 3. I might need another column over here. What else? How about negative 4 and 9, negative 9 and 4, negative 6 and 6. So those are all my options that multiply to be negative 36. Do any of those add to be 5? Shoop. So I'm going to put negative 4x here and 9x here. It didn't matter which order I put them in the box. But you want to look at the first row by itself. What is the greatest common factor? Well, they both are divisible by 2. They both have an x. 2x times what is 2x squared? 2x times what is negative 4x? And then what's got to go on the bottom row to make it work? What do they have in common? Well, they're both divisible by 9. Let's double check. 9 times x? 9 times negative 2? Check. Now I want you to try the ones on the following page to turn in. I will have a key with the sub, so if you run into one where you're really having trouble, you'll be able to look at it.